This is the laboratory exercise number 4, analog input and potentiometer. Analog input and potentiometer focuses on understanding how analog input works through the use of potentiometer connected to the Arduino Uno R3. This lab exercise includes designing the circuit, connecting the potentiometer to the analog input pin, and running the code that responds to the changing voltage. The circuit construction and the testing are performed using Tinkercad, while the code development is done through Arduino code. Moreover, the concept of it, like the analog signals, voltage variation, and microcontroller input processing, to be explored within virtual setup. The analog is used to process signals that change continuously over time. It is also composed of passive electrical elements such as resistors, capacitors, and inductors, together with active components like transistors. It also defines that these parts are connected in different ways. They create circuits that can amplify signals, reduce noise, or create waveforms. Moreover, it works with continuous signals that are widely used in various electronic devices and control systems. And here's the process of creating my own design and circuit for analog input and potentiometer. In conducting the laboratory exercise number 4 entitled Analog Input and Potentiometer, I performed the experiment using alternative simulation tools since I do not have access to the actual electronic components. I designed and assembled the circuit using Tinkercad, where I virtually connect step by step the Arduino Uno R3 and the potentiometer. During the simulation method, the center terminal of the potentiometer is connected to the A0 analog input pin of the Arduino, while the other two terminals are connected to the 5V and GND pins to complete the circuit configuration. After constructing the circuit with the provided code in the lab manual, I input the program using Arduino IDE, and the code worked as is, reads and processes the analog signals created by the potentiometer as its position changes. I then run the code within the alternative simulation I used to observe how the Arduino responds and interprets the varying analog input values. Within this process, my circuit design successfully works. And now it's time to finalize my paper.